Hello all. In this video, I'm going to review quick architecture about Hive. So look at the funny picture here, and then yes, this is more funny picture. Before diving into iceberg architecture, it's important to understand how Hive queries are executed on file directories. Very important. File directories, not on files. This image depicts a humorous analogy comparing Apache Hive SQL execution engine to the concept of searching for something in an inefficient way. The person in this image is seen sticking his head into a haystack, such symbolizing a cumbersome or brute force search process, such as like Hive traditionally performing queries by scanning through entire data set. It is like finding a needle in a haystack. So if you ask for a query, and it is in a partition or a particular directory, Hive has no information how to open a file for based on your query. It opens all the files in the directory and sweep through and then finds your data. So Hive runs on file directories. So it's like finding a needle in a haystack. So it often scans large volume of data. So even with your where class filters, even with your where class partition filters, Hive has to open that particular partition or partition directory and open all files, then apply your filter condition. For example, you ask for give me a user who lives in Bolingbrook, Illinois. But all Illinois data in one particular partition, which is Illinois partition. So Hive will not able to find a data file where a person living in a Bolingbrook of Illinois, or a person living in Telangana, Hyderabad, or Telangana, Hyderabad, Balanagar. So that information is stuck in somewhere in some files. So Hive has to open all those files, read each file, and find the location of that person who lives in Hyderabad, Balanagar. So it's like finding a needle in a haystack. So the Hive has to stick in, so basically has to sweep through the entire Hive haystack, then find the needle. In iceberg, it's the opposite. It knows where is that needle is. It's like indexing. It knows exactly random access. It knows exactly where to go and find that particular needle. So, and iceberg runs on individual files. So that's the difference. So they change the architecture in a simplistic way. Looks like that, but from a high level. So instead of dealing with the directories, file directories, the iceberg design on file level. So that's how its Hive query engine is working previously, and then they modified the Hive query engine, look at the file level. That's what the iceberg is going to be. So I want to establish in this class that, okay, you need to understand how Hive works and then how queries are working. Then we look at how the partition pruning works. If we give a where class of your partition key, and how partition pruning will not work if you have a wrong format of your partition key. Then later we will compare with iceberg hidden partitions. Okay, so this is how engine overview. So Hive engine, very important, runs on all the files in a directory. Okay, so on quick introduction here. So to establish the base for migrating to iceberg, we need to understand Hive. So here, to establish a baseline to assess how migration from Hive to iceberg table can drive a 10x performance improvement. Okay, so we're going to create a Hive table. So initially we created a first Hive catalog configuration. So open up a Hive catalog configuration and then declare a variable name called db name, db, or you can have any database name. If you are running on your cluster, then you can use your database name. Here, we're going to use most of our class is Spark SQL. So all you need is just spark.sql and everything is SQL, ANSYS SQL here. So create database. If not exist, then since we are creating a Hive database, we're going to use a Spark catalog and database name dot, database name, or you can hard code the database. But here, we create a variable here. Then always try to use, 3 quotes here, 3 quotes. That way, you can do line wrapping. So you're going to create a database, show databases. Now look at this one, this show databases, and then you need to show. Then you can add, how big, how many rows you want, and what is the wide, and all the stuff. Then create another database here, DB2, then run the DB2 here. So multiple databases. Then after that, if you want to drop a database, then drop database. Then if you already have a tables, then use cascade. Okay. So drop database cascade. That means it's also going to drop the tables if this particular database DB2 has any existing tables, and you cannot drop it if there is a tables are there. So you need to use a cascade. Then show databases, right? And then you want to know what tables a particular Hive database has. So here, use database, use your database name, of course, your catalog name. Then let's go to very quickly in a Hive catalog just before we, here. This is a Hive catalog configuration. Then if you see here, and Spark catalog to create a Spark tables, then Iceberg catalog for create Iceberg tables, and then we are using a Hadoop configuration here. So now let's go back to one more time, back to our example. And so here, that's why whenever you want to create a Hive tables, use a Spark catalog and then database name. Then when you use this one, you're going to see the Hive database, and then Hive tables only. So here, show tables, then you can see the tables. Now if you look at here, I want to see, 100 rows and then wide of, So if you put more wider here, then you will, let's say you have big files name or big table names or path names and all that stuff. So whenever show tables, okay. So now in this session, we'll learn about introduction to Hive database. We create a database, drop a database, use a database, show databases. Then once you use database, show tables. That's how we're gonna. And as we are progressing, we're gonna look at more features of Hive. Okay, so this is basically an introduction to Hive, and then Hive basic. The next we're gonna create a understanding Hive partition, non-partition table. Thank you.